In this video, we are given that z equals to a plus bi all over a minus bi. And we are also given that the imaginary part of z is 1. All right. And then we are asked to prove that a equals to b. All right. Let's do that. So I'm going to quickly rewrite my z here. Z equals to a plus bi all over a minus bi. Right? Remember, ladies and gentlemen, if I'm working with fractions in complex numbers, I always need to multiply by the conjugate of the denominator. So the conjugate is a, and then you write bi. The only thing that changes is the sign. So this was a minus, now here you have a plus. And you do the same on top, so that it's like we're multiplying by 1 basically. You don't change the meaning of the equation. And then put everything into the brackets. Right. So now let's try to simplify this and see where we're gonna go to. Remember, this will foil that, and this also foils that, and so on. Right. So a times a, you can see that a times a is a squared. A times bi is plus abi. And then this times that is plus, so here we have abi, not ab squared, abi plus another abi plus b squared I squared, right, all over. At the bottom, I'm sure you can see that is difference of 2 squares, so this will multiply that and that will multiply that. The middle terms are going to cancel each other, so no need to, right? So we have a squared minus b I squared and squared, right? And then let's keep on going. On top, we have a squared plus these two are like terms. So we have 2abi, right? And then let's see. We have plus b squared plus b squared. Wait. Let's erase that. So b squared. I remember I squared basically will change to -1, right? I squared is -1. And then at the bottom, we have a squared minus b squared, and then the I squared changes to -1. Then now let's see. We're going to have, if you check here, b squared times -1 is negative b squared. So we're going to have a squared minus b squared as your first part, and then plus 2abi as your second part. All right. And then I'm going to divide both sides by, okay, let's do this. It's a squared plus b squared, because negative b squared times -1, it's positive b squared. And then, ladies and gentlemen, we are going to have this now. We're going to have let's see, we're going to have a squared minus b squared all over, I'm separating the imaginary part and the real part, all over a squared plus b squared plus 2ab all over a squared plus b squared, and then here there's an I, right? Sharp. You can see that this will be the real part of z, that will be the imaginary part of z. But we are told that the imaginary part of z is basically, let's go back up. They told us that the imaginary part, they say the imaginary part of z equals to 1, right? And we are proving that a equals to b. Okay, that's fine. Let's go back here. So guys, we know that this is the im of z, right? Because it's the coefficient of I, that is the im of z. So im of z will be equals to 1, which means 2ab all over a squared plus b squared will give us 1, right? And then we're going to have LCD. This is over 1, so I'm going to multiply this there basically, so that the LCD is the same. All right, so we have this now. We have a plus b and then all squares, and then we have a squared plus b squared, and then we can see now that the bottom is exactly the same, right? So it's going to fall off. So we have 2ab equals to a squared plus b squared, right? And then we have 0 equals to a squared minus 2ab plus b squared. So this guy comes this side, right? And then now we can see that we have a perfect square trinomial, which means we are going to have the exact same two brackets, right? So a squared breaks into a, and then the b squared breaks into b and b. I mean b and b, not b squared, né? And then we take this sign, so it's minus and minus. I always check my trinomial, remember. This is AB, so it's 1AB with a negative, and then this is also a negative AB. So when I add a -1 and a -1, I get a -2AB. So that is true. Now applying zero product principle, I know that the bracket will be equals to 0, but because I have the same bracket, I'm going to just do this. And then I can easily move the b to the other side, so b equals to a. And then in bracket, we have proven this. So this has been proven. All right. And that's it for this video, ladies and gentlemen. Thank you very much. Aluta continua.